Okay, so we are going to look at this problem we just did with section 5.5 example 3, and we used the compatibility. And we can't really, if you do it this way, you have to make the correct assumption. So it's always better to add them together and know that they equal 0, because one's going to have a positive twist and one's negative, even though they're going the same way. It's because of that right-hand rule coming from the right, we're twisting that way. From the left, it's towards us. Okay, and that's positive, but if we're twisting all of it that way, we're going to have a positive twist and a negative twist. So I said we would look at this same problem using the force method. So if I were to set this up, I'm going to have the same equilibrium. So my equilibrium is still going to look something like this. And I have 6 kip inches, and I have, it doesn't matter, we're just going to call them both this way this time, torque at A and torque at B. And if I sum my torques, then I'm going to have TA plus TB equals 6 kip inches. Now, if I go back and I remove a redundant, so we're going to look at that deformation. And we're going to remove the redundant. Then let's remove B since it's right here next to us. And I'm going to have the torque at A. I'm going to leave that, and I have 6 kip. Actually, we don't want to do that because that we have so much extra steps, because we'll have two different diameters. So let's do this. Let's keep the torque at B. Let's do 6 kip inches, and then we are removing my redundant at A. So if I look internal, there is 0 torque happening here, okay? Because if I cut it, 0 torque, 0 torque. So now let's cut it here. So if I cut it right here, I can see then my internal, if I have 6 kip inches, then positive is coming towards me, like so. And so that's going to be the torque from D to B caused by that. And when I sum my torques, I'm going to find that torque dB equals negative 6 kip inches. Okay, and the rotation then, the rotation that comes from that is going to be TL over JG. So I have negative 6 kip inches, and then I have the length of 12 inches divided by pi over 2.5 to the 4th, and we're not going to include G because they all have the same material. Now I've got to put A back on. So that was removing the redundant. So now we're going to put A back on. So if I put A back on, I have the torque at A. I don't use that force anymore, and I have the torque at B. Okay, I have the torque at A and I have the torque at B. So now when I come back through here and I make a cut anywhere, so here's my torque at A. I'm going to assume internal positive, that internal part positive, and I sum my torques equals 0. The internal torque anywhere from A to B has to equal the torque at A, right? It's twisting it back. And what is phi from that? Well, phi is going to have to come from, I have a different geometry here than I have for the rest of it. So I'm going to have that torque at A times 5 inches divided by pi over 2.25 to the 4th plus, okay? Then I have all of this is the same material. We've removed that force. So it's going to be the torque at A times 20 inches divided by pi over 2.5 to the 4th. And this is going to be the phi from my torque at A. This is my phi from the actual torque on the system, okay? And so I know that these two have to, they have to come back to 0. So I know that phi of t plus phi of TA has to come to 0. There is no deformation. So I have negative 6 times 12 divided by pi over 2 to the 0.5 to the 4th plus, okay, 5TA over pi over 2.25 to the 4th plus 20 TA, pi over 2, 0.5 to the fourth, all of that nonsense equals 0. And as I go through here, I can take out the pi over 2, and I'm going to move that over. So I have 5 TA over 0.25 to the fourth plus 20 TA over 0.5 to the fourth equals 6 times 12 over 0.5 to the fourth. And see, this way is much easier because you don't have a system of equations. I'm going to kind of like draw a line here. You don't have that system of equations. And so it's just easier math. So I have 5 enter, 0.25 enter to the fourth divided by 20 enter, 0.5 enter to the fourth divided by plus, and I have 1600 TA equals 6 enter 12 times 0.5 to the fourth divided by 1152. So TA has to equal, swap, divide, 0.72 kip inches, which is exactly what I got using the compatibility method. So it doesn't matter which way you do these, you just have to be consistent in whatever system that you're using. And I just think this way is easier because it's just a lot less work. So